Now let's go through a few types of questions that you can handle based on the information that we just covered. The first question, is negative 3, 8 a solution to 2x plus 3 equals negative y? We want to remember that a solution is what numbers can we put in place of the variables to make the equation true. This ordered pair gives us a value for x and a value for y, so we just need to check if x equals negative 3 and y equals 8, is our equation true? So I'll rewrite this equation, and in place of x, I'll substitute negative 3. I'm copying down the plus 3 that's in this equation, and getting over to where we see a y, there's a negative in front, so I'm keeping that negative there, and in place of y, we're substituting 8 from the ordered pair that y equals 8. So I want you to see that we've taken this equation exactly. We have not made any changes. All we did was put in our numbers in place of x and y. 2 times x, negative 3, plus 3 equals negative y, and y is 8. So the exact same equation that we're given, we've substituted in our numbers, and now we want to see, is this equation true? For checking if a number is a solution, really the idea is, are the two sides of the equation equal? Are they the same? So we'll keep the two sides of the equation separate and simplify each side. On the left side, we're multiplying first. 2 times negative 3 equals negative 6. And next we are adding 3, and it equals negative 3. The right side of the equation is pretty simple already. Opposite of 8, or negative 8, however you want to see that. We've got one negative, so it makes our answer a negative 8. And it looks like we are not left with a true equation. Negative 3 and negative 8, not the same thing on both sides. So is it a solution? No way. Now this type of a question we usually only see early on when we're studying linear equations in two variables. We are actually given an ordered pair solution to try. A number for x and a number for y, and all we need to do is see if when those numbers are plugged into the equation, does it make the equation true? If it does, it is a solution, and if it doesn't, like in this example, it is not a solution. Here's an example for you to try, so pause the video to try this one, and now we'll look at the answer together. Is this ordered pair, negative 4, 3, a solution to 6x plus 7y equals negative 3? The ordered pair tells us x equals negative 4 and y equals 3, so let's substitute those numbers into the equation. 6 times x is now 6 times negative 4, plus 7y, 7 times y is 7 times 3. Does that equal negative 3? Now we're keeping the two sides of the equation separated and simplifying the two sides one at a time. And the right side is already completely simplified, negative 3. So let's do the order of operations on the left side. 6 times negative 4 equals negative 24. 7 times 3 equals 21. And negative 24 plus 21 equals negative 3. So we have a true equation. We saw negative 3 on both sides. The same number on both sides of the equation means that we had a solution. So that ordered pair is a solution to this equation. Here's the next type of problem to cover. What is the solution to 3x minus 2y equals 10 when x equals negative 2? Now this problem, we're not given both x and y to check to see if it is a solution. We're after what is the ordered pair. What are the values for x and y that would make this equation true? But we're given that x equals 2. We're already started with an ordered pair solution where 2 is the first number because x equals 2. We need to find out what the value of y needs to be when x equals 2. Remember, when we have the value for one variable, we can plug that number in place of the variable, and it makes our equation go from two variables down to one variable. We know that x equals 2, so we can recopy this entire equation, but substitute 2 in place of x. 3x is 3 times 2, minus 2y equals 10. The question is asking us to find this value for y, so we have an equation that will solve for y. And since it's the only variable in this equation, we'll be able to find what number does y equal. Let's first simplify the equation and do the 3 times 2 equals 6. And now we'll go through our usual moves for solving an equation with one variable, isolating the variable. We'll take away 6 from both sides. Leaves us with negative 2y. Be careful there, it's 6 minus 2y, so we need to bring down the negative 2y. The right side, 10 minus 6 equals 4. And now divide both sides by negative 2 to see that y equals negative 2. This is an excellent example of what we would do if we have one number from our ordered pair solution. We'll take that number, substitute it into the equation, and then we can solve the equation to find the other. We knew that x equals positive 2, so we put that right in place of x. We solved for y and found y equals negative 2. So our ordered pair solution has x equals positive 2 and y equals negative 2. Here's a similar problem, and it's one that you can pause the video and try. And now we'll look at the answer together. What is the solution to 5x minus y equals 8 when y equals 7? So we're rewriting this equation, 5x minus, in place of y, we substitute the value 7. And keep copying the equation, it equals 8. Since we've put 7 in place of y, we're left with an equation that has just the variable x. 5x minus 7 equals 8. So let's solve this equation for x. Add 7. Make sure we're doing it to both sides. 5x equals 15, so when we divide by 5, x equals 3. So the ordered pair solution is 3, 7. Remember, our ordered pair always has x as the first number and y as the second number. So even though we started this problem by using 7, that was the value of y. So it needs to come in the ordered pair second. And the value for x, 3, comes first. Here's our next problem type, and it's actually the moves that we'll end up doing very frequently with the work that we'll continue to do with linear equations in two variables. The last two types of questions are ones that we really see at the beginning of our studies to really get a sense of our understanding of linear equations in two variables and their solutions. What we end up having to do most often is not start with an actual ordered pair and check if it's true, or even just start with one variable and see what the other value would be, start with x and find y, or start with y and find x. Most of the time, we start an equation complete clean slate, and we have to on our own come up with an ordered pair, a value for x and y. And in this question, we need to find 3 different ones. We talked about solving by inspection, just looking at an equation, doing some mental math to figure out ordered pair solutions. But a strategy that we'll use much more often is choose a value for one of the variables, plug it in, and find the other. So basically using that last example as a bridge to handling this type of a question. Now there's no specific way that we choose numbers on our own. We usually just pick small numbers. 0, 1, 2, maybe a negative 1 or negative 2. So I'll choose to start with x equals 1. And now I just need to figure out what is the value of y that goes with x equals 1. If x equals 1, this equation becomes 2 times 1 plus y equals 9. And now an equation in one variable, we can solve for y. 2 plus y equals 9, so take away 2, and y equals 7. So there's one ordered pair solution. And we can repeat these steps with other values for x. Let's choose if x equals 2. So we'll rewrite the equation, but put 2 in place of x. 2 times 2 plus y equals 9. So 4 plus y equals 9, and this shows that y equals 5. There's another ordered pair solution. Should we just keep moving in the same direction, choose x equals 3, and figure out y? We can do that. 2 times 3 plus y equals 9. 6 plus y equals 9, so that means y equals 3. And there's our third ordered pair solution. So how about an example for you to try? It's one notch up from the example that we just looked at, but you'll use the exact same steps. Just be a little bit more cautious as we solve the equation. So we're trying to find three ordered pair solutions for the equation 4x minus 2y equals negative 6. And go for that strategy where we'll pick some values for x, put them into the equation, and see what does y equal, and that's how we'll find ordered pair solutions. So pause the video and try it, and now we'll look through the answer together. Now I can't say for certain that I'll choose the same ordered pair solutions as you, but I'll choose a few examples and we'll see if we have some things matching up. Let's start with x equals 1. So that means our equation becomes 4 times 1 minus 2y equals negative 6. And we can solve this equation for y. 4 minus 2y equals negative 6. Let's take care of this term, the positive 4. Take away 4 from both sides. We're left with negative 2y here on the left side. And negative 6 minus 4 equals negative 10. Then we want to divide both sides by negative 2 because it's being multiplied to y, so we want to do the opposite, divide by negative 2. Our variable y is isolated, and on the right side, negative 10 divided by negative 2 equals positive 5. So one ordered pair solution would be 1, 5. For the next solution, I'll pick x equals 0. It's actually a very common choice because it can make these steps go a little bit quicker. We'll see in the future it becomes very common that we choose 0 to go in place of a variable, and I'll show you how that looks. 4 times x is now 4 times 0, minus 2y equals negative 6. The 4 times 0, I actually don't even need to write that term at all because anything times 0 equals 0. So we're looking at 0 minus 2y, which is really just negative 2y. So those steps we can begin to skip over in the future because we know when you put a 0 in place of the variable, it makes that entire term equal to 0. And we're left only with the other term, negative 2y equals negative 6. And just one more step to solve for y. We're dividing both sides by negative 2. Y equals positive 3. So we have another ordered pair solution, 0, 3. For our last ordered pair solution, we'll choose x equals 2. And I'll squeeze some space in right here. X equals 2. So I have that much of the ordered pair figured out. Putting 2 in place of x in this equation, 4 times 2 minus 2y equals negative 6. Simplifying 4 times 2, we've got 8 minus 2y equals negative 6. We'll take away 8 from both sides. It leaves us with negative 2y equals negative 14. And lastly, dividing by negative 2, y equals positive 7. So there's our third ordered pair, 2, 7. Now as we move ahead into more problems about graphing, we'll see that we take this same approach over and over and over again for finding ordered pair solutions. That we'll choose one number for a variable. It may be x or it may be y. We put that number in place of the variable in the equation and solve that equation for the other variable. And that gives us ordered pair solutions. And I think it's good for us to end this example with a look at plotting these 3 points because we know that they should all line up on a straight line. 0, 3, 1, 5, and 2, 7. Here are those ordered pair solutions, 0, 3, 1, 5, and 2, 7. First, let's plot 0, 3. Starting from the origin, horizontally 0, not at all. And vertically 3, so up 1, 2, 3, and there's our point. Next 1, 5, so horizontally positive 1, and vertically positive 5. Next point 2, 7, horizontally 2, vertically 7. And we see that our 3 ordered pair solutions do line up. What we'll do in the future, once we have some ordered pairs plotted, we'll connect those points with a straight line. There's a straight line right through those points. We'll put an arrowhead on this line to indicate that the line extends forever, even off of the coordinate plane, so beyond values of positive or negative 10. And this is a graph of the equation that we started with, 4x minus 2y equals negative 6. This line is the graph of the equation because it represents all of the points that are ordered pair solutions. Any other point on the line, let's say the point right down here, Starting from the origin, we would need to go to the left, negative 1, 2, 3, 4, x equals negative 4, vertically down, so x and y are both negative. Y is negative 1, 2, 3, 4, 5. So our ordered pair, negative 4, negative 5, and when we put negative 4 in place of x, and negative 5 in place of y, it will make the equation true. Be careful here, negative 2 times negative 5 becomes positive 10, and negative 16 plus 10 does equal negative 6. So that's showing that it is a solution to the equation, and we want to know going forward that once we find a few of our own ordered pair solutions, and we see that they line up in a straight line, we connect the points with that straight line, because the line is actually made up of the millions and billions and trillions and unlimited number of different ordered pair solutions. They could be integers, like the few that we have here so far. They could even be fractions, but they represent numbers for x and y, that if we plugged those numbers in place of x and y in the equation, it would make the equation true. And any other point that we can find that's not on the line, like this point 2, 2, since it is not on the line, it is not a solution to the equation. If we put 2 in place of x and 2 in place of y, we do not get a true equation. 8 minus 4 equals 4. Does not match up with negative 6. So not on the line, not a solution. On the line, it is a solution.